Now we'll discuss the relationship between the definite integral and an area under the curve. So in order to do that, let's recall two formulas. We have rate times time equals distance, and the fact that the area of a rectangle is its base times its height. Another thing that would be nice to recall is that when we take the integral of a function, it's usually a derivative function with respect to x, and then our antiderivative is just an f function. If we have a derivative like people per year or dollars per month, when we take the integral of that, then we're left with just the people or just the dollars. So let's consider, with this example, we're traveling for a constant 70 miles per hour driving across country. That is what we're used to calling our rate, right? 70. I'm going to write it as miles per hour. Notice that is a derivative. It is a miles per hour. So we can refer to that as an f prime. And we know if we're looking for distance, we would normally take that 70 miles per hour and multiply it by however many hours. 70 times 1 hour means we went 70 miles. 70 times 2 hours means we went 140 miles. Well, what they're asking us to do here is to represent the velocity as a function of time. So our velocity is v of t, and we're going to represent it in a graph. So let's consider this graph here, where this is time, and here's our velocity, v of t. Now, they gave us a velocity of 70. And if we're traveling at a constant 70 miles per hour, then that is going to be just a straight horizontal line for whatever time t that we have. And then it's asking us what is representing then the distance traveled by the graph. Well, notice over here on the left, we figured out that the distance would be 70 times t. Well, whatever our t is, if we multiply 70 times t, that is also the area of that rectangle. Because we have a base here of t, and we have a height here of 70. So we have an area equaling that distance. Well, if you think of it, again, our rate is miles per hour, and you multiply it by the hour, we're left with just the miles. But here's where the relationship is with the integral. Let me scooch this up just a little bit. If we were to take the integral of that rate, we would be left with just the distance, which is the miles. We also found out that the area under the curve was also the distance. So guess what? The integral of some function is going to be the same thing as the area under the graph of that function. So that's just to kind of give you the concept of what we're going to be doing and why we're doing it. So the area of the curve, f prime of x, gives us an accumulated total of f of x over that interval. What do we mean by accumulated total? Well, let's imagine whatever curve that we had, that we can split that up into just little bitty rectangles. And we found the area of each of those rectangles and added them all up. So we found the distance at this time, the distance at this time, the distance at this time, and we added them all together. Then we know that not all graphs fall above the x-axis. So when we say under the curve, we just mean between the graph and the horizontal or x-axis. If we're looking at this graph to the left, we have an area A1 falling above the x-axis. That entire area is going to be positive. Area A2 between A and B is below the x-axis, so that's a negative area. So when they ask you for the net area, they are wanting us to subtract those two areas. Which one's larger, the positive area or the negative area? So we would go ahead and just find the integral from 0 all the way out here to b. Basically, area of A1 minus area of 2. If, however, they don't care about the positive and negative, they just want the total area, we would have to split it up. The positive area we can do as is, all the way from 0 to A, but then we'd have to subtract the negative area from A to B. Remember, minus a negative equals a positive. We'd have a positive area minus a negative area. So basically that would add both of those together. Another way that we could do it is to take the integral of the absolute value, but that's only for using a calculator.